Okay, today we're going to look at magnetic fields generated by charges. We know so far that if I have a charge, it emanates its own electrical field. But if I have a moving charge, this moving charge is going to create an additional field, which is actually a magnetic field. So we're going to look at three separate situations where we have moving charges moving through conductors of various shapes, and we're going to look at the shapes of the magnetic fields which are created by these moving charges. So the first and simplest way that a charge can move through a conductor is through a straight line conductor. So over here I have a wire, right, straight wire, and in this wire I have a current traveling through. Okay, the method that I would use in order to tell the the magnetic field direction as created by the current is using the right hand grip rule. Okay, and I'm gonna pull out a picture that's gonna show you that. Okay, so the grip rule looks like this. I'm gonna draw my right hand, and this is how the fingers would look like. Please forgive the drawing. 4 fingers to a hand, and rounds of the hand. Alright, so over here, that's my thumb. Yep, that's the thumb. The thumb is going to point in the direction of the current. Okay, that's the current. And these fingers, you can see that they're all curled up like this. These are going to point in the direction of the magnetic field. Okay, so that's the direction of the magnetic field. That's the fingers. Okay, they'll curl in the direction. So we use this same principle and apply it to my current carrying conductor here. This is a straight line conductor. Okay, let me just write that down. Straight line conductor. This is my first example. Example 1. Okay, so we can see that the field is going to be in this direction. So it's going to, this is the front of it, and that's the back of it. Those are the dotted lines. Okay, so if you're doing this on your own, using your own hand, you can see that this is the direction that the magnetic field will be drawn in. Okay, so there you go. That's the first part. Okay, the second one that we have is we're going to take this straight line conductor and we are going to shape it into a coil. So a coil will look something like this. So this is a coil of wire, and the current is going through it. So current is going through like this, right, all the way. It's moving this way, and it's circling here and returning back to its source. Okay, so that's the current going through. Okay, so this is the second one. This is a coil of wire. Okay, so we're going to apply the same rule here. Using the right hand grip rule, we're going to apply it to this side. We can see that the thumb, okay, will move in the same direction as the current. So the current direction is this way now. That's I. Okay, it's going this way. Okay, and therefore you get the same curve as before. Okay, so your fingers will curl in this direction, and they'll go back around it, and it's the same thing, right? I'll just draw 2 for good measure, and then around it, and you can see that's how the magnetic field looks. Same thing here as well. We can do it for every part of this coil. So it's going to be this way. That's the current right now at the top, and then if you use your thumb and curl your fingers around the wire, you'll be able to see that it curls this way, and then to the back, this way, and then to the back. Okay, so if you curl it properly, it'll appear like this. This is the front, and then the back part moves in this direction. Okay, now we get to the final part of the wire. This is downwards like this, and if you apply your right hand grip rule again, you'll be able to see that this is kind of the direction that it moves in. So you have it to the front, it's coming out of the coil like this, and then it's moving to the back again, and then out. So you can see that the overall movement is that you have this outpouring of a magnetic field from the center, right? So you have the magnetic field is coming out of the coil like this, and it's circling back and re-entering through the back like this, and it's coming out again. The same thing this way. You can draw it this way, magnetic field going out, and it's circling back and coming back in the other way around. So that's how the magnetic field is like. It's going through the back and coming out through the front. Okay. Now, finally, we have a third situation, and this third situation is going to be that of a solenoid. So a solenoid is actually a collection of coils. Okay. So I'm going to take all these coils, I'm going to bundle them together into around a core, right? A metal core, a magnetic core. So I'm going to draw this core. So this core looks something like this. Okay, so it's just a hollow metal conductor. But no current is traveling inside the conductor. It's only traveling through the wires that I'm wrapping around the conductor. So wrapping the conductor around with a coil, and there are many, many more coils wrapped around. So it's a collection of coils. It's like if I took the second situation and just multiplied it many, many times over. Okay, so it all appears like this. Just quickly draw the rest. Okay, so it's something like that, and then it comes back out again. Okay, so once again, I get a current going through the coil. Okay, this is the current, and it's traveling around. It's coming through this way. Okay, all down like this, and finally it exits there. Okay. Now I can use the right-hand grid rule and analyze the magnetic field for each of these coils, and you will quickly realize that the magnetic field is actually traveling in this direction for every single coil. It's like this, going like this, and then it's curving to the back. It's going like this, and it's curving to the back for every one of these wires. So the overall effect for all of the coils combined is that you're getting a magnetic field which is circling like this in the front. It's going like this, and like this. This is the magnetic field, right? That's B. And it's entering into the core, and it's coming out through the back, like that. And then it circles it again. Right. Same thing is happening on the opposite end, except you have the magnetic field going like this into it, and then in the back, it's something like this. Okay, and it goes in, in the back, and the back, and the back. So what's happening here is that you are actually creating two poles. You can see that the magnetic field is entering one side and exiting the other end. So on this side, you have the North Pole. Oh, sorry. On this side, you have the North Pole. That's where the magnetic field lines are coming up from. And on this side, you have the magnetic field lines entering again. That's where you have the South Pole. And we can apply the same concept over here as well. We can see that at the front here, we have the magnetic field lines coming out. So this part here is the North Pole. And at the back here, we can see that the magnetic field lines are entering again, and that's where you have your South Pole. So there we go. That's how we determine the magnetic field lines for 3 different connections or current carrying conductors.